Continuing our topic about rational functions, here I'm going to, in this video, I'm going to cover transformation of rational functions. So, let's start. Based on a given function, f of x is equal 1 over x, we want to transform into function f of x is equal 1 over x plus 2 minus 1. Okay, how are we gonna do it? So first of all, we know that x plus 2 is a change of x, and if x plus 2 is equal 0, then x is equal negative 2, which means we are going to transfer shift the graph 1 over x by negative 2. Let me do it. Actually, let me start doing from here. It would be better. So first of all, let me graph uh, 1 over x Yes, this is how looks graph 1 over x, and x cannot be equal 0 in denominator, so our vertical asymptote gonna be x is equal x is equal 0, right? Next, this is 1 over x. Now we need to shift it to 1 over x plus 2. So this is my 2. And the graph is gonna look like gonna shift by negative 2, right? So this is 1 over x plus 2. This point is negative 2, shifted by negative 2. And lastly, we need to build 1 over x plus 2 minus 1. Okay. Minus 1. Practically, what do we have? We have vertical asymptote negative 2. So horizontal asymptote, let's figure out. Negative 2, it's vertical asymptote because x plus 2 cannot be equal 0, x cannot be equal negative 2, correct? So that's our vertical asymptote. Horizontal asymptote, I can represent as 1, I can represent in the format of x to power 0 because it's equal 1, right? Over x to power 1 plus 2 minus 1. So because 0 is less than 1, meaning n is less than m, therefore our horizontal asymptote is going to be equal 0, because if n is less than m, horizontal asymptote is 0, and then we have here also minus 1 we need to consider, which will be negative 1, which is the same thing as you take the whole this graph and shift down by negative 1. So this is -1. And this is how gonna look our final graph. It's gonna go from this vertical asymptote, from this graph to this graph, and it's gonna go from here to here. This is how it's gonna look like. So this graph is 1 over x plus 2 minus 1. This is how we did transformation. Next example. Now let's do different one. F of x is equal 1 over x squared minus 3. Okay, so we need to, hold on, transform f of x is equal 1 over x squared, transform into f of x is equal 1 over x squared minus 3. All right, so let's see. What is going to be the 1 over x squared? It's going to go like this. So next, we're going to convert to transform, rather saying, one over x squared minus 3. How are we going to do? First of all, our vertical asymptote, 1 over x squared minus 3, vertical asymptote is going to be 0, right? So vertical asymptote is 0. Let's see horizontal asymptote. 1 I can represent as x squared, x to power 0 over x squared minus 3, right? So because n is less than m, horizontal asymptote is going to be equal 0. And then we have here minus 3, so it's going to be -3. So vertical asymptote 0, horizontal is going to be -3. Let me build that asymptote. 0 is this one. And -3 is going to be our horizontal asymptote. And this is how it's going to look our graph. Okay, otherwise, the other way we learned is x doesn't have any shift, so the only shift is your y, so bring it down by -3. That's another way to do transfer. Okay, next one. Let's say we have graph f of x is equal 1 over x squared, And we need to transform to f of x is equal 1 over x minus 3 squared plus 2. Now, the way we learn practically, x minus 3, x is going to be shifted by positive 3, and then moved up, it's a change of y, move up by 2. So that's the same thing coming out. Vertical asymptote is going to be, it's going to be, let me see, it's going to be positive 3, right? And horizontal asymptote is going to be 2. Let's show this. So x minus 3 squared cannot be equal 0. That means x minus 3 cannot be equal 0. X cannot be equal 3. So vertical asymptote is equal 3. Right? Horizontal asymptote, where one I represent again x to power 0 over x minus 3 to power 2 plus 2. So we have n is equal 0, m is equal x squared, which is 2, right? It's here 1. 1 times 2 is 2, which is n is less than m, right? So horizontal asymptote is equal 0. But then we have also this plus 2. It's going to be equal 2. So either by horizontal asymptote, vertical asymptote, you can transfer, or you can transfer the way I taught you, change of x and change of y. So x is going to change by positive 3 shift, and y is going to be shifted by positive 2, practically. So let's draw this graph. Our x squared, oh god, x squared I meant, okay. Obviously I'm drawing approximately, they have to be symmetric and identical, I mean very similar. So it comes to x 1 over x minus 3 squared. Let's build. Okay. This is going to be your shifting, vertical asymptote. The graph is going to look like this. We shift this graph by positive 3. And then from here, so this one is 1 over x minus 3 squared. And then from here, we're going to shift it up by 2, right? Which is going to be our horizontal asymptote, 1 and 2. This is 2, and our 3 is right here. So the graph, it's going to go so this is 1 over x minus 3 squared plus 2. Okay? Okay, now let's see how we're going to graph rational functions. Graphing rational functions. So what are the steps we need to cover? to graph rational functions. Step number 1. We need to check on whether or not the graph is symmetric. So, symmetry. We need to see if f of negative x is equal f of x. Then we have a even function and it's symmetric about y-axis. Okay? Let me see. Well, okay. Number 2. And also we are checking on symmetry of about origin or about x. So f of negative x, if it's equal negative f of x, then we have symmetry about x axis. Okay? Next step, it's going to be y-intercept, x-intercept, and step 3, it's going to be vertical asymptote, horizontal asymptote. All right. Let's start with the following graph. F of x is equal 3x minus 3 and x minus 2. So let's go through first step, symmetry. So f of negative x is equal negative 3x minus 3, because we are plugging everywhere negative x minus 2. This is going to be equal, take negative out, 3x plus 3. Here we take negative out, x plus 2. And the answer is 3x plus 3 and x plus 2. So as we can see, f of x is not equal f of negative x. So it doesn't have symmetric graph about y-axis. And negative f of x, if I put negative f of x, it's going to equal negative 3x minus 3 over x minus 2, which is the same thing. I can put equal 3 minus 3x, x minus 2, or I can change x at the bottom, 3x minus 3 over 2 minus x. So this negative, in this first case, negative I applied to numerator. So where 3x became negative, 3 became positive. And in second case, I applied to the denominator, where x became negative and 2 became positive. So either one way or another. But more importantly, we can say that negative f of x is not equal f of negative x, right? This is negative x, this is negative f of x. So it's not equal, which means it doesn't have symmetry. Next one we are going to cover, it's going to be intercepts. Okay. So we are assuming x is equal 0 Y-intercept is equal question mark. So let's plug f of x, plug 0. F of 0 is equal 3 times 0 minus 2, 0 minus 2. And that is equal negative 2 over negative 2, and that is equal positive 1. So this is our y-intercept is equal 1. 0, 1. Next. Y is equal 0. X-intercept is equal question mark. Y is equal 0 or f of x is equal 0. It's the same thing. Y is same thing as f of x. So what do we get this time? 2x minus 3 over x minus 2 is equal 0. Now we know that bottom cannot be equal 0, otherwise we would get division by 0. So the only thing is left to be equal 0 is 2x minus 3. If 2x minus 3 is equal 0, 2x is equal 3, x is equal 3 over 2. So x-intercept is 3 over 2, which is 1.5, and 0. Okay. So let me see. So where do we have 0, 1? This is 1 intercept, and the other one 3.5, 1.5. It's going to be right here, and 0 intercept. Okay, and the third one we need to find vertical and horizontal asymptote, right? So, vertical asymptote, it's we can find out by plugging x minus 2 that cannot be equal domain. X cannot be equal negative 2, which is our vertical asymptote is equal to 1.5. This is our 2. Well, not precisely. Well, yeah. Okay. This is our vertical asymptote. Next, horizontal asymptote. For horizontal asymptotes, 2x, it's going to be 2x minus 3 over x minus 2, right? So let's see. Our n is equal m, because here we have 1, here we have 1. Therefore, horizontal asymptote is going to be 2 over 1. This is this 2, and then here is 1, right? 2 over 1 is equal 2. So this is our horizontal asymptote. Where is our, this is 1, this is 2. Right? So this is our horizontal asymptote. Those are our intercepts. And we know the graph is not symmetric, so let me move it to more spacey place. Here. And our graph, it's gonna be like this. And it's gonna cross like that. So this will be 2x minus 3 over x minus 2. Okay? Next one. Next one is going to be f of x is equal x plus 1 over x minus 2 minus 3. So let's start checking on if graph is symmetric or not. F of negative x is equal negative x plus 1, negative x minus 2 minus 3. Okay? So as we can say, f of x is not equal f of negative x. Next, negative f of x is equal negative x plus 1 over x minus 2 minus 3. So we can say that negative f of x is not equal f of negative x. Here is not equal. Therefore, we don't have any symmetry here. Step number 2. We are going to figure out the intercept. So if x is equal 0, y-intercept equal question mark. So which means f of 0 is equal 0 plus 1, 0 minus 2, and minus 3. So which will be equal negative 1 over 2 minus 3, and that's equal negative 3 and 1/2. So our intercept is going to be 0 and negative 3 1/2. Right? Now let's find x-intercept. Y is equal 0, or f of x equal y equals 0. And from here we have, so x-intercept is equal question mark. So x plus 1 over x minus 2 minus 3 is equal 0, correct? So because if it's equal 0, let me bring to, from here I will have x plus 1 over x minus 2 is equal positive 3, right? I'm moving on this side. So what's going to happen? If I bring to common denominator, it is going to be x minus 2, right? Which means x minus 2 here times x minus 2 here. So same denominator I'm dropping, because if denominator is same in equation, that means we can drop the denominator. So we have from here x plus 1 equal 3 times x minus 2. So that will be x plus 1 is equal 3x minus 6. So from here, 1 plus 6, I'm moving 6 here, and x I'm moving here. So that will be 3x minus x. 7 is equal to x. And we divide by 2. And we get 7 over 2 is equal x. Which means our x-intercept is going to be 7 over 2, comma 0. Okay. Let's build the graph. I mean, the elements of the graph. Where is our x-intercept? It's right here. I mean, this is y-intercept, negative 3.5. This is negative 3.5. And x-intercept, it's going to be also 3.5. Here it is 7 over 2, 3.5. So 1, 2, 3, 4. So also 3.5. All right. So far so good. Now let's move on. Find the vertical asymptote and horizontal asymptote. So for vertical asymptote, number 3. So to find vertical asymptote, we are going to take the denominator to remind you our rational function is x plus 1 over x minus 2 minus 3. So for the vertical asymptote, our denominator, right, has to be equal 0, which means x minus 2 cannot be equal 0 in this case, which is a domain. X cannot be equal 2, which means our vertical asymptote is equal 2. Let me graph vertical asymptote. This is our 2. This is 3.5, right? This is 2. Vertical asymptote. Now let's solve horizontal asymptote. X plus 1 over x minus 2 minus 3. What do we get? So n is equal m, because here is 1, here is 1. That means horizontal asymptote is equal 1 over 1, right? It's going to be 1 over 1 and minus this 3. So it's going to be negative 2, which means our horizontal asymptote is going to be negative 2 right here. Okay, and this is how our graph is going to look like. So the graph is going to go like this, crossing this intercept. And in this point also crossing this intercept. See, it crosses intercept here. Okay, so this graph is x plus 1 over x minus 2 minus 3. Now, you can have equation if it goes, let me see, like this way, or it goes, let's say this way, right? Or can be this way. For that case, you can take any value of x. Let's say you want to take value here to see where is it crossing. Find out how much the x is. Plug in the equation that x and see how much your y will come out. Okay? That's how you can do. Let's say you want to know at the point, this is 1, this is 2, this is 3. If you want to know where it's going to be at the point 4, this point, how it's going to go. So you take x equal 4. So let's see. 4 here, 4 plus 1. 4 minus 2 minus 3. 4 plus 1 is 5. 4 minus 2 is 2 minus 3. 2.5 minus 3. It's going to be negative. Wait a minute. Yeah, 5 over 2. It's going to be 2.5 minus 3. It's going to make negative 0.5. So 0.5, it's going to go somewhere like this. Right? So it's going to be here, your y. If this is 4, this is 0.5, negative 0.5, this is 4. So you plug, you get the point, and then you get the curve precise way. All right? Another one. Let's graph another one. F of x is equal x plus 1 over x squared minus 1 minus plus 2. Okay, let's get going. First one, it's not symmetric, so we go straight to, how many I solved? Let me see. 1, this is 1, this is 2. Well, we solved 2. Okay, let me do pick up a little bit different one. Let me see. I'm going to pick more the different type of, since we solved already this type, like something like this. So let's solve this one. X squared over x squared minus 9. Let's solve this graph. Okay? Wait a minute, with this problem, I think, okay, well, let's build it. Let's build it. So regarding symmetry, f of negative x is equal negative x squared. Here we have negative x squared minus 9. Right? That is going to be equal x squared over x squared minus 9. Bingo, we have f of x is equal f of negative x. So we're going to get symmetry here in this case, right? All right, that's good. So now let's find our intercepts and then asymptote so we can move on. So next is going to be our intercept when x is equal 0. Actually, let me write down with green. When x is equal 0, y-intercept is going to be equal 0 over 0 minus 9. So that's equal negative. Oh, that's equals bold 0 because you have 0 on the top. So it's going to be, intercept is going to be 0, 0. And when y is equal 0, x-intercept is gonna be, so x squared over x squared minus 9 is equal 0, right? Since we know x squared minus 9 cannot be equal 0, then the only thing left to become 0 is x. Why x squared minus 9 cannot be equal 0? Because your denominator can never be the equal is 0. Okay? So therefore we have only top left to be 0. Is if it's equal x squared equals 0, that means x is equal 0. And your intercept is 0, 0. So it looks like both intercept in the 0, 0. So let's start building elements on the graph. So our point is going to be, intercept is going to be 0 right here. Okay, number 3, we need to find vertical asymptote and horizontal asymptote, right? So for vertical asymptote, we need to put x squared minus 9 cannot be equal 0. X cannot be equal plus minus 3, right? Which means we have vertical asymptote equal negative 3 and 3. Correct? Let's build 1, 2, 3, and 1, 2, 3. So 1 is going here, negative 3. The other one is going here, positive 3. Negative 3, positive 3. And let's figure out also horizontal asymptote. So for horizontal asymptote, 2x x squared x squared. So x squared minus 9. So our n is equal m, right? Therefore, horizontal asymptote is equal 1 over 1. Here is we have 1, here we have 1. Correct? So it's going to be equal 1. And finally, we can build the graph. Our two at the vertical asymptote break the graphing area into 3 parts. So let's see how our graph is gonna look like. We said at the beginning the graph is symmetric, right? So this one is gonna be symmetric to this one. And it's both of them running to 3 by absolute value, correct? So they have to be symmetric, use your imagination. Okay. And the other part, the x squared, it's gonna run like this. Okay, and that's how the graph is gonna look like. Okay. I will graph one more. And that is gonna be f of x is equal. So let me mark down where is each one. So it would be easier for you. Graphing, this is the first one. This is the second one. Example, graphing. This is third one, graphing. And I'm going the fourth one. I will fly a little bit faster here because you already know, but so I want you to see this one also. So x minus 4 is equal x squared minus x minus 6. So let's start. Symmetry. F of negative f is equal negative x minus 4, negative x squared minus negative x minus 6. It's from here it's already clear to me that it's not going to be equal. So it's equal negative x minus 4, you get x squared plus x minus 6. So f of x is not equal f of negative x. So it's not symmetrical. Now about y. Now if I put also negative f of x, it's going to be negative x minus 4 over x squared minus x minus 6, which means this negative I'm going to apply to denominator, which will be 4 minus x. X will become negative, 4 will become positive. And here x squared minus x minus 6, which means f of negative f of x is not equal also f of negative x. So it's not equal to this one also. All right, there is no symmetry in there. Next, number 2. Intercept. When x is equal 0, y is equal, so 0 minus 4, and then it's going to be 0 plus 0 minus 6. So it's going to be negative 4 over 6. It's going to be 2/3. Right? So intercept is going to be 0 and 2/3. Now, if y-intercept, when y is equal 0, x-intercept is equal. So x minus 4, x squared minus x minus 6 is equal 0, correct? So what does that mean? We need to solve it. So since x squared minus x minus 6, this cannot be equal 0. So the only thing can be 0 is x minus 4, right? So, and that means x minus 4 is equal 0, x is equal 4. This is your x-intercept. 4 and 0. Let's build the graph. So, where is my point? 1, 2, 3, 4. 4 and 0. And then we have 0 and 2/3 right here. 1, 2, 3, 4, 0 and 2/3 right here. Okay, the other point. All right. Now let's go through vertical asymptote. So for vertical asymptote, we said denominator has to be equal 0, right? So x squared minus x minus 6 cannot be equal 0, which means breaking down x minus 3, x plus 2 cannot be equal 0. From here, x is equal 3, cannot be equal 3, x cannot be equal negative 2, correct? So vertical asymptote is negative 2, positive 3, correct? All right, let's build it. Negative 2, positive 3. 1, this is positive 3. And negative 2, it's going to come here. So this is negative 2. This is positive 3. And horizontal asymptote? Let me bring this graph down. Okay, so for horizontal asymptote, what do we have? X minus 4, oops. Over x minus 3, x plus 2. I am writing in this format, so, okay, well, I can write down in original format. So it will be, what was that, x squared minus x minus 6. Okay, so our n is equal 1, here it is. Our m is equal 2, here it is. So horizontal, it's less than n is less than m, right? Which means horizontal asymptote is equal 0. So here it's going to be our horizontal asymptote. Okay, how is our graph gonna look like? So because here we know it's gonna cross this 3, that means it's gonna go like this. And because this one, it doesn't crossing anywhere in negative part, so it goes like this. And remember, we said it's not symmetrical. They are not symmetrical. And this part is crossing here, so it's going to go up. If you want to know precise point, you just can take, let's say in this area, you want to know if it's curve here or curve here. So at this point, you can take any point of x, calculate how much will be your y, and draw it precisely. Okay, you have plenty of examples, so I'm done.